Another application of dimension analysis is in the determination of units. As I said, that you are having a formula, but finally you don't know what units should I use. You can use dimension analysis that can simplify the whole work that you have to do, and finally just simply write your units. So simply write the dimensional formula of a given formula, then thereafter convert each dimension to a specific unit. As you know, if dimension is mass, the unit is kilograms. If it is t, the unit is seconds. If it is length, the unit is distance, which is meters. So this is easy for simple equations like given force is equal to mass times acceleration. This is just simple. You know that force is equal, you find the units of force, you write the dimension. You know, dimensions of mass are m, dimensions of acceleration are l, t minus 2. So finally, you know, from here you have kilograms, you have meters, and you have seconds per negative 2. Simple. Similarly, if you asked units for mass, you can just put mass the subject here, so that you have mass is equal to force over acceleration. Then you write dimensions for this and dimensions for this, you conclude and you write the units. Another example is that, for instance, you have a formula, you find the what you want to know, the units of K. So but you know that they're related to pressure time and mass and velocity, in this sense that pressure times mass time over velocity is equal to the value, the quantity K. So you know that dimensions of K, just show their dimensions of K is equal to dimensions of pressure, which this way. I'm sorry that these things have to stay in your head. These dimensions, they are very simple, though after you do a number of questions they just stick in your head. So you know, dimensions of pressure are there, dimensions of mass are there, dimensions of velocity, you put them there, so there is no problem. You simplify the whole pile of work there, and you get simpler or the total dimensions. Finally, you can conclude the dimensions of K, the units of K from the dimension is equal to m, where m was mass, so automatically it becomes kilograms squared. As you can see, L is length, so automatically it becomes seconds per negative 2. I mean meters, meters per negative 2. And we have time here, where is raised to per negative 3, so time becomes seconds per negative 3. Simple. Another example, another function of dimensional analysis is determination of units. Issues get complicated. Actually it's just a continuation, I didn't notice. I wanted to include this complicated example because, as you can see here in the previous slide, that here we are asked dimensions of mass, and we actually converted this mass. We made a subject of this mass, and finally we simply found an expression here, and we got our units. But issues become complicated in such an equation. Now you're asked dimensions of A and V. What are the dimensions of the constant A and V and B? You can't simply make A and B subjects here unless you are very good mathematicians. Otherwise you'll spend years solving one question. But the happy thing is that you don't have to make this thing the subject here. There's just a simple way of solving this, so don't worry, that's why I'm here. So you can never, kwa mfano umeulizwa 2 mangoes plus 2 oranges, hamna kitu kama hiki, itabaki 2 mangoes plus 2 oranges. You cannot just simply add two things which are not the same. So you can't say that these are 4 mango oranges. No, there is no such thing. It is impossible. Same to dimensions. Only quantities that have the same units will be added. For example, velocity will be added to a velocity, or pressure will only be added to a pressure. So using this logic, our question is solved in a very easy way. If you're given all questions of such kind, you just solve them by using these examples, that if a is added to a velocity, then a must be a velocity, so dimensions za velocity ndo hizo hizo za a. Similarly to here, that ukiangalia hapa, p is added to this component here, as you can see. So automatically we know that this component here is equal to dimensions of pressure, because only dimensions of pressure can be added to pressure. Pressure can only be added to pressure. Automatically, if we know dimensions of p ni pressure, ni sawa na dimensions za a v squared. If we know that p dimensions zake ni sawa na za a v squared, then from here simply we have a, that our a is equal to p times v square. So from here we have dimensions are a, simply we have dimensions are p times dimensions are v squared. From here dimensions are a, we know that pressure dimensions are ni hizo hapa. Dimensions are volume squared, we know dimensions of volume ni meters cubic, so we have L cubic, so we can square them hapo, we get dimensions are v squared kama unavyoziona hapo. Finally we have dimensions of a, simply kama hivyo hapo. Finally we have also dimensions of b. We only know according to our principle that velocity can only be added, this v for this case ni volume. If v is added, is subtracted or added to, is either addition or subtraction. If v is added to b, then automatically b must be like v, so dimensions are b ndo hizo hizo za v. So automatically if v is volume, then automatically b must be volume. Ndo inakuwa namna hiyo, simple tu, that if b is equal to volume. So maswali haya huwa ni mengi, so cha muhimu ni kutumia hiyo principle to remember that only quantities which are the same, having the same units, having the same dimensions, can be added or subtracted. So finally write your units from dimensions come up. Remember that the question here asked actually the dimensions, but usually they ask units, and most of the students they end in the dimensions. If you asked units, you have to proceed from here. You can simply get the units, that this is meters cubic, and from here you can get kilogram, meters power 5 seconds squared. Simple.